Okay, so for the new topics is we're gonna learn on vector value function. Okay, so for the first subtopic, okay, so previously you learned about vectors, okay, in engineering mathematics 1, okay, SSCE 1693. Okay, so you learn about so many things, I believe. Okay, equation of line, equation of equation of plane, okay, angles between two plane. Okay, so previously when we have a vector, so we can write like this, right? The component x, y and z, let's say. Okay, so this is how we write the vector. Okay, vector in the previous subjects. Okay, so now it's no longer as a normal vector, we have vector function. Okay, so let's take a look on the definition of vector function. Okay, it's actually as a function whose domain is a set of real number and range is a set of vectors. Okay, so previously you learned about domain and range in the first chapter. Okay, in the first chapter we let's say if you have a function of x, y, okay, equal to x squared plus y squared. Okay, so we can write as z equal to x squared plus y squared. Okay, so from this given function, we know that x and y will be the real number, and then this one is the domain. Okay, and z is real number, so this one is the range for the given function. Okay, so we can see that actually x, y and z is real number. Okay, but now, okay, so we have vector function. Okay, so the general form of vector function is given by this one. Okay, so we have function of t here. Okay, where f, g and h now is a real value function. Okay, and we also call as this one as the component function. We call it as a component function of R. Okay, so now here t is independent variable. So we can say that, okay, so the domain here that we got is actually the values of t. Okay, so let me give you examples. Okay, let's say if I give you the vector function like this. Okay, you should know how what should I say, the list or the possible values of t, so that you will be able to understand the second subtopic after this. So let's say if you have a vector function like this, ln t I plus t minus 1 j plus e of negative t k here. Okay, so if we write, we can rewrite as this one also, okay, e of negative t. Okay, so from here actually you know that based on this function, okay, based on this one, so this one is x, this one is y, and then this one is z, right? Okay, so based on x, okay, so based on component of x, we know that t, okay, the values of t, okay, should be greater than 0 because we have function ln here. Okay, so this is the first condition that you should what should I say, you should consider. Okay, so let's see for y. Okay, for y we have t over t minus 1. Okay, so based on y, we know that t cannot be equal to 1. If not, it will get undefined. Okay, so means that the domain, okay, the values of t cannot be equal to 1 based on this function. Okay, and then there's no restriction for z here because it's exponential function, right? So there's no what should I say, there's no restriction. Okay, so based on that given vector function, so we can say that the domain, okay, should be between 0 up to 1, where 0 and 1 is not included. And one more thing that, sorry, okay, so we have to separate into 2 because of the condition of y. Okay, so because y, okay, t cannot be equal to 1, so that's why we have to split into 2. Okay, so it's not necessary to split into 2, but it depends on the based on the given vector function. Okay, so we will see the values, how can what is the importance of the values of t when you want to move to the second part, which is graph a vector function here. Okay, so like I mentioned, we let rt here as a vector function. Okay, so suppose that the initial point of the vector rt is at the origin. Okay, because we are dealing with time now. Okay, so obviously that we're gonna have initial, and also we also will have terminal point. Okay, so actually as based on the vector function, okay, so you will actually get a curve in space. Okay, a curve in space like this graph. Okay, you actually will get this kind of curve. Okay, with the increasing values of t. If you can see here, okay, if you can see here actually, okay, so this one is t equal to -1, t equal to 0, t equal to 1, t equal to 2. Okay, so basically this line or this curve in space is actually like a path. Okay, we call it as particle path. Okay, with the increasing values of t. Okay, that is the keyword, increasing values of t. So that's why the values of t or the domain is important. Okay, because you have to if you want to get the graph of a vector function, you need to consider the values of t. Okay, because this curve is, what should I say, the sketching. Okay, you will get the curve in term of increasing values of t here. Okay, so the next one is, okay, so we can say that this vector, okay, so this vector is called as particle position vector at t naught. Okay, so at this point, okay, this line is actually the position vector, okay, at t equal to -1. Okay, so for this one is actually the position vector at t equal to 0, and this one is actually the position vector for t equal to 1, and so on. Okay, so whenever you have specific time, okay, so we call it as position vector at a certain time that you set. Okay, that is the idea on how can we get the graph. Okay, so let's see for the first example. Okay, so for the first example, okay, so for the first example, we have the component for RT that we got is 3 minus T, 2, -4 plus 3T here. Okay, so we know that for us to be able to sketch on 3D, right? Okay, because we are looking for a curve in a space, right? So the first thing first is to set as x equal to 3 minus t, y equal to 2, z equal to -4 plus 3t. Okay, based on the given vector function. Okay, so this one will be the first equation, second equation, and the third equation. Okay, so from the first one, okay, we can rewrite as t equal to, make it t as what should I say, as a subject. So we will have 3 minus x. Okay, so this one will be the fourth equation. So we're going to substitute this fourth equation into the third equation. So you will get z equal to -4 plus 3. T here is 3 minus x. Okay, so you will get, after you simplify, you will get 5 minus 3x. Okay, so now we have one more term here, y equal to 2. Okay, so we have y equal to 2, and then z equal to 5 minus 3x. Okay, so previously we have, okay, we have a plane like this, right? No plane, exists like this. Let's say y, x, z. Okay, so how can we get the graph for given vector function? Okay, so you have to convert from parametric equation into the Cartesian coordinate, means that we convert. Okay, there's no more terms t here. Okay, so from here you will see that you will actually get another what should I say, new axis. Okay, so let me change the color so that will be clear. Okay, we know that is y equals to 2. Okay, it should be somewhere here. Okay, so this one will be the new axis. New axis. Okay, this one is y equal to 2. Okay, so no matter what values of t that you gonna substitute after this, okay, so that what should I say, position vector should be in this new axis. Okay, so we will see after this. Okay, so now we have figured out our new axis, right? Okay, so next one. Okay, so to get the direction of a curve, okay, because we need to know, okay, so we know that is actually on the new axis, okay, based on the parametric equation that we have convert. Okay, so we got the new axis. Okay, how can we get the direction of the curve? Okay, direction of the curve. Okay, so to get direction of the curve, okay, direction of curve. Okay, so I have mentioned previously that it's actually the curve with the increasing values of t. Okay, so the idea is to choose any value of t which is in the domain, okay, so based on the given vector function, we know that there is no restriction for values of t, right? 3t here. Okay, so based on this one, okay, it's not like the previous example that I showed to you, okay, because we are dealing with the fraction and also with ln. Okay, so there's no restriction for t. Okay, so t can be any values. Okay, so since I said that the curve should be raw with the increasing values of t, okay, so we should choose t. Okay, so we should what should I say, you should decide the value of t depends on you, as long as increasing values of t. Okay, with the increasing values of t, so let's set t equal to 0. Okay, so from here, if we set t equal to 0, so our position vector that we got is 3 minus 0, 2, negative 4, plus 0 here. Okay, so this one will be 3, 2, negative 4. Okay, so the increasing values of t, right? So let's say if we choose t equal to 2. Okay, so the second position vector should be 3 minus 2 here, 2, negative 4 plus 3 times with 2 here. Okay, then the coordinate should be 1, 2, 2 here. And then normally to get it's not perfect sketch, at least you can imagine the curve, okay, if you set up to 3 point. Okay, so let's choose one more point, t equal to 3. Okay, so if you substitute values t equal to 3 into the given vector function, you will get 0, 2, 5. Okay, so now you got the position based on the chosen values of t here. Okay, we got the coordinate now. Okay, so now we'd like to sketch. Okay, so here. Okay, so this is the normal axis. Okay, so this one is y, this one is z, this one is x. Okay, okay, just now I said that we're gonna have new axis. Okay, so we will see new axis should be somewhere here. Okay, somewhere here, should be like this. Okay, so this is actually the new axis. So we will see that the position vector will be on this new axis. Okay, so let's see t equal to 0. We know that the coordinate just now is 3, 2, negative 4. 3, 2, negative 4. Okay, so it's actually, if we, let me make dot line here, dotted line. Okay, so this one is 1, this one is 2. Okay, so this one is 3. Okay, so from here you will see that this one is 1, 2, 3. Okay, so the coordinate for t equal to 0 is 3, 2, negative 4. Okay, so one more thing is actually from here. Okay, should be a negative 1, negative 2, negative 3, negative 4. No, it should not be here. It should be somewhere here. Okay, okay, it's not, should not be here. Okay, so this one, let me change the color so that you won't be confused. Okay, so this is the negative z-axis. Okay, so actually if we imagine this one is negative 1, negative 2, negative 3, negative 4. Okay, so actually you see the let me change the color. Okay, so 3, 2, negative 4. 3 is for x. Okay, here. Okay, so y is 2. So we have draw this one, right? Should be like this. Okay, and then negative 4. So it should going down here. Okay, so it should be somewhere here. Okay, because this one should be, okay, I think because of my axis it should be a straight line, right? Okay, so it's actually the connection should be somewhere here. Okay, so it's actually here, negative 4 here. Okay, for r 0 here. Okay, so the next one is if 2 equal to 2 here, we got that 1, 2, 2 here. 1, 2, 2. Okay, so let me change the color again. That's black. Okay, 1, 2, 2. 1, okay. 1 here, x1, y is 2 here. We can, should be somewhere here. 2, 2 here, should be somewhere here. 1 goes to 2 and then move to that one. Okay, so this is actually the position vector for r equal to 2 here. Okay, so this is the first position vector that we got, the second position vector. And the last one, when we choose 3 equal to 3, you will get that 0, 2, 5. Okay, 0, okay, 0x, 2y here, and then 5. Okay, it's somewhere here. 0, 2, and then 5 here. Okay, so let's just extend this one up to 5. This one as 5. Should be it's not in that line. 2 is somewhere here. 0, 0, 2, and then 5. It's 2 up to here, and then move a little bit here. Should be somewhere here. You actually will get a straight line for this one. Okay, so this one is actually r equal to 3. Okay, so here you will actually get a straight line like this. The curve should be straight line like this. Okay, it's actually a straight line with this direction, in this direction. Why? Because of the position vector that we have. We have, what should I say? We have determined at the beginning of the step. Okay, so I will share this the graph, okay, in the WhatsApp group, okay, when I share these videos. Okay, so that will be clear because of my bad sketching. Okay, so I will share the details, okay, with my handwriting so that you can see clearly. Okay, so this is how can you actually get the graph of a vector function. Okay, so I think this one, it will be a little bit tricky because of the you obviously will get a straight line that is actually located at the new axis actually. Okay, but then a little bit hard to imagine. Okay, so let's see the second examples. Okay, so the second examples, we have rt. Okay, for the second example, they give you the component is 3 sine t, negative 3 cos t, and then 2 here. Okay, so from here you get x equal to 3 sine t, y equal to negative 3 cos t, and then z is equal to 2. Okay, so from here actually, if you square both sides, okay, and then plus y squared, you actually will get 3 squared sine squared t plus with negative 2 squared cos squared t. Okay, so you definitely will get 9 sine squared t plus cos squared t. Okay, so based on the identity, you will get 9 times 1. So actually you will get x squared plus y squared equal to 9. Okay, so definitely you will get a circle. Okay, but what is the what should I say, the position of that vector function on space? Okay, so if we sketch 2D, you will get this one is actually xy. Let's sketch on 2D first. Okay, so you will get a circle like this. Okay, but do not forget about this one is z equal to 2. Okay, so actually you will get like this. Okay, so this one is y, this one is x, so this one is z. Okay, so this happen at z equal to 2 is somewhere here. So you actually will get a circle that will be on z equal to 2. Okay, so this one is z equal to 2. Okay, so you actually will have a plane with the circle shape floating at z equal to 2. Okay, so the next part is you have to decide the what should I say, you have to decide the direction of the position vector. Okay, before this, okay, for the previous example, to be able to sketch, you need to set for certain values of t. Okay, so right now from the parametric equation, okay, you can just straight away get the answers. Okay, so to get the sketch or the graph is a little bit easy compared to the previous one. Okay, but then how can you what should I say, get the direction? Okay, so the first thing first, okay, so actually the new axis, okay, so just now for the previous example, our new axis on at the plane at y equal to 2. Okay, so now our new axis should be in this plane. It's at z equal to 2. So this is actually the new axis. Okay, so this one is 2 here. Okay, so we know that it's actually a circle with radius 3. Okay, so this one. Okay, so for this one is actually okay, sorry, let me, okay, so to define or to get the direction of the vector, okay, to get the direction of the vector function, okay, so since we are talking about a circle, okay, so we know that it's actually involved with angle. Okay, so we know that this one is starting with 0 up to pi, 3 over 2 pi, and then 0 pi over 2 here, pi here, and then here is 3 pi over 2, and then up to 2 pi. Okay, so for this kind of shape, okay, it will be easy if, let's say, if you choose t equal to 0. Okay, you substitute the values of t equal to 0 into this one. Okay, so you will get, okay, the position vector for t equal to 0, you will get 0, negative 3, 2. Okay, 0, negative 3, 2 when you substitute values of t here. Okay, value of t here. Okay, so here you get r 0 for 0, negative 3, 2. What about if we choose r at the position for pi? Okay, so that's here you will get 0, 3, 2. And the last one, if we choose 2 pi, okay, you will get 0, negative 3, 2. Okay, so actually the position, or I should say the values of t, okay, the values of t here is depends on either you want to choose a 0 pi over 2 Okay, 3 pi over 2 also can. Okay, because from here we know that the domain for t should be between 0 up to 2 pi, right? So you can choose any values of t. Okay, so from here you will see that the direction, okay, so here, okay, 0, 0, -3, 2, okay, should be somewhere here. -3, right? -3 for y, okay, somewhere here. Sorry. R equal to 0. Yes, this one is for R equal to 0 here. Okay, and the next one for R equal to pi here, 0, 3, 2. Okay, 0, 3, 2. Okay, 0, 3. Okay, 3, 2 should be somewhere here. Okay, so this one is the position vector for t equal to pi. Okay, and the next one, okay, the direction should be here. Okay, so obviously if you choose 3 pi over 2, you will see the position vector should be somewhere here. Okay, because if you choose 2 pi, it's gonna back to this point, right? So this one is actually for 2 pi also. So the direction should be like this. Okay, so whenever you sketch the graph, make sure that you include the direction of the curve. Okay, because it's one important component in graph of vector function. Okay, I know it will be easy to get the graph. Okay, but then how can you identify the direction of the curve? Is depends on the increasing values of t that you figure out at the beginning of the question. Okay, so we will see a pattern of question from final exam. Okay, so that will be clear enough. Okay, so that's all for this video.